Maurice Ravel is a renowned French composer best known for Bolero with its repetitive and altering structure. When Ravel was composing Bolero, scientists believe he may have been suffering from frontotemporal dementia, or FTD. FTD is diagnosed as the atrophy of the frontotemporal cerebral tissue as well as associated behavioral disorders. Some studies have found that certain types of FTD lead to more creativity, which Ravel expressed through his music. While increased artistic skills and decreased cortical thickness have been observed in FTD-affected brains, no studies have looked into whether increased cortical folding or brain growth occurs in the unaffected regions of the brain. Therefore, we propose that asymmetrical FTD, which causes degeneration of neural tissue in the frontal and temporal lobes of one hemisphere of the brain, may increase neural tissue growth and cortical folding in the unaffected half of the brain.
To conduct this study, we obtained MRI scans of 3 healthy subjects and 3 subjects with dementia from an open-source database, all male between 60 and 70. We used FreeSurfer to analyze high-resolution MRI scans to measure values such as the average cortical thickness, surface area, gray matter volume, folding index, and intrinsic curvature index. These values were particularly interesting for our study since they can indicate the amount of brain tissue and hence the degree of brain development and growth in an area. In this study, the folding index, which measures how much the brain folds like a piece of paper, and the intrinsic curvature index, which measures how much the brain curves similar to a dimple golf ball, were used instead of the gyrification index. We expect more active parts of the brain to have a greater cortical thickness, volume, and indices, and we expect the opposite for parts of the brain affected by dementia.
Here's all our raw data. It's very overwhelming. So what do these numbers mean? First, it shows our methods are robust enough that we can still identify some regions affected by FTD. The right hemisphere's superior frontal gyral region had statistically significant differences in both thickness and folding index. This finding corroborates the fact that FTD occurs in the frontal lobe. Our goal, however, was to identify regions of the brain with FTD that had increased growth by looking for increased values in all 4 measurements for the FTD group, including folding index. We found that the left hemisphere middle temporal, left hemisphere superior temporal, the right hemisphere inferior temporal, and the posterior cingulate cortex regions in both hemispheres met these criteria.
Typically, we see more growth in the left hemisphere than in the right. On one hand, it makes sense that the left hemisphere of the brain would have more regions with potentially increased growth if the right hemisphere has more regions affected by FTD. However, it is surprising that many of the regions are in the temporal lobe, which is typically also affected by FTD. The increased growth in the posterior cingulate cortex, or PCC, is also intriguing. Although the PCC's function is mostly unknown, it is part of the limbic system and may contribute to a person's artistic talents. The temporal lobe is linked to audio and visual information processing, so the growth of brain tissue and the consequent increased neural activity in the unaffected temporal lobes may actually support our hypothesis. To reiterate, the left hemisphere of the brain had increased growth when compared to the right hemisphere. For future study, it is necessary to analyze more subjects in MRI scans to establish statistically significant differences in both thickness and folding index. Although FTD has drastically changed many lives, it is interesting to see that it can create something so beautiful, as Ravel showed with his creation of Bolero.